Number 9. An annuity due paying $1 for n plus 2 years has a present value of 13.987. An annuity due paying $1 for n years has an accumulated value of 51.632. Calculate the effective annual rate of interest. So at first look, some people might think that you would need a financial calculator in order to solve this question, but a lot of times you can do it through pure algebra. So let's write down the equations that are given to us. So an annuity due for n plus 2 years at some interest rate has a present value of 13.987. We can also rewrite this as 1 plus an annuity immediate for n plus 1. Therefore, the annuity immediate itself for n plus 1 years will be 13.987 minus the 1 for a total of 12.987. And this will help us later on, as you'll see. Now for our second equation, we have an S double dot angle N, which equals to 51.632, which we can also rewrite as S n plus, or an angle n plus 1 minus 1. Therefore, S angle n plus 1 will equal 52.632. And what this achieved is getting an annuity immediate and an S angle n plus 1 for the same time frame. Now we can use one of our identities learned in class, and that is S angle n plus 1 divided by A angle n plus 1, and this only works when the time frames are similar, will equal to the 1 plus interest rate for time period n plus 1. And because we know the value of S angle and the value of A angle, we can figure out what 1 plus I n to the power of n plus 1 is. We figure out that it is 4.05267. Now, the question asks us for the effective annual rate of interest. Well, we can figure this out simply by expanding what S angle n plus 1 is, which is simply 1 plus I to the power of n plus 1 minus 1 divided by I. Well, we have the value of the first term, which is 4.05267 minus 1 divided by I, which will equal our value for S angle n plus 1, which is 52.632. Therefore, we get that I equals 0.058, which is equivalent to 5.8%.